What material has excellent construction properties, is used today in many civil engineering projects, has hundreds of industrial applications, and can be extremely useful around the home? The answer is slag, the construction material of choice. The lava that came from those ancient volcanoes in our early days yielded basalt formed from molten rock, a widely used construction material. However, slag can also claim to have been used in construction applications as long as the so-called natural or igneous rocks. There are those who believe the appearance of industrial slag products in the cement, concrete and quarrying industry is a new phenomenon. This is not true. History tells us slag was used by the ancient Romans in sections of the famous Appian Way. And in the 18th century, Europeans were moulding slag into building blocks. But in this presentation, we will not be concentrating on igneous rocks created millions of years ago or the slag of yesteryear, but the slag which comes from a modern, sophisticated, quality-controlled industrial process during the manufacture of iron, steel and various metals. Let's look at the several different ways we process these useful and adaptable co-products. To produce iron, a blast furnace is charged with iron ore, together with coke as a fuel and limestone as a fluxing agent. Two products are obtained from the furnace, iron and as a co-product, slag. It comes from the furnace as a liquid at temperatures of about 1500 degrees Celsius. The different types of blast furnace slag produced depend on the manner in which the molten slag is cooled and solidified. Once it is cooled, the slag is dug by conventional quarrying equipment and loaded onto vehicles where it is taken to processing locations. From this moment, slag is treated like any other quarry product and processed in modern crushing and screening plants. Air-cooled blast furnace slag is slightly lighter than most natural aggregates and has excellent self-cementing properties. It is interchangeable with natural rock in any normal quarry product application. Slag provides an excellent road pavement base or sub-base material. The Australian Road Research Board, which is Australia's foremost authority on road construction, has produced favourable reports based on exhaustive trials of slag pavements against controls of natural rock pavements. The F6 tollway between Sydney and Wollongong on the New South Wales south coast was built in 1975 using blast furnace slag. This high-speed, heavily tracked freeway has and still performs extremely well despite crossing several underground coal mine subsidence areas. Certain blends of slag road bases are self-cementing. This unique property, which gives extra strength, represents an opportunity to reduce costs through more efficient design. Overseas experience has proven that where it is available, blast furnace slag is a preferred material for airport runway pavements. Extensive field testing by the Australian Federal Airports Corporation concluded that blast furnace slag is highly suitable for airport runways. Subsequently, slag was used in the construction of the third runway at Mascot, Sydney, and continues to be used in further construction projects. Uncrushed slag is also an ideal material as a select fill for civil engineering projects. State Rail in New South Wales nominated uncrushed blast furnace slag as a preferred fill material and has used significant quantities to stabilise embankments in mountainous slip areas. The use of granulated blast furnace iron slag is also rapidly increasing in the cement and construction industry. This unique material is produced after the molten slag leaves the blast furnace and is passed through a trough of high-pressure, high-volume water sprays. The heat energy contained in the molten slag causes it to explode and instantly form a granulated blast furnace slag. On casual examination, granulated blast furnace slag would pass for river sand with a top size of about 5 millimeters. Granulated slag can be used in several forms, but generally as a stabilizing agent without any further processing, or ground like cement to any required fineness to meet customers' specific needs. An important application of great significance is the ability to produce manufactured sands from air-cooled blast furnace slag fines. This product is used as the fine aggregates in concrete. Black sand is another form of manufactured sand of a similar size to river sands, which is granulated from molten zinc slag. Both of these products have the ability to replace diminishing natural sand resources. The use of these manufactured sands reduces drying shrinkage in the concrete produced. Also, black sand has reduced water requirements in concrete manufacture. The ability to blend these manufactured sands to customers' precise requirements is an additional advantage. Granulated slag has proved to be an excellent select fill behind reinforced earth wall construction. The most beneficial use for granulated blast furnace slag is when it is ground and added to ordinary Portland cement to form an enhanced slag blended cement. Concrete experts will tell you one important indicator of reliable concrete is its workability, a rather vague term, but highly important to producing quality concrete. Workability governs the ease of handling or getting a uniform placement into formwork, ensuring good contact with reinforcing, eliminating voids and segregation of fine and coarse aggregate. Slag cement concrete's workability is outstanding. Its pumping characteristics are excellent. Its slightly longer setting time is an advantage in hot weather, as it allows more time to work the concrete. Other advantages include slag cement's low heat of hydration, so reducing the risk of cracking, particularly in large concrete sections. An interesting feature of cement containing ground granulated slag is that it produces concrete which has a much greater resistance to sulfate attack and chloride ion penetration compared to ordinary Portland cement. Two specific examples relate to the marine cement developed for use in the Sydney Harbour Tunnel submerged tube concrete tunnel segments and innovative floating oil extraction platforms used in Bass Strait. The Sydney Harbour Tunnel segments formed nearly a kilometre of four-lane tunnel across the bed of Sydney Harbour and contain 200,000 tonnes of sulfate-resistant concrete. The cement used in these projects contained around 60% ground blast furnace slag.
Blue Circle Southern uses approximately 250,000 tonnes of granulated slag in the manufacture of cements that are designed for very specific uses. And the slag is used to modify the cement to a situation where you can't readily achieve that with ordinary Portland cements. Some of these applications range from the ordinary handyman using something like builders cement and slag meant, to the more exotic like the marine cement for chemical durability. So Blue Circle Southern employ the chemistry that's possible with this type of product to modify the cements that they generally make. And the involvement in this has been over many, many years, so we obviously see a future in the use of granulated slags, especially for the cementitious materials. And the incorporation of these with slag aggregates will certainly produce concretes that far outstrip the current durability and that's possible with normal concrete technology.
Marine cement was specified by the Roads and Traffic Authority of New South Wales in the concrete pile caps for the Glebe Island Bridge project in Sydney. Each cap contains nearly 3,000 cubic metres of concrete.
We used marine blend cement in the concrete for this project to control the thermal curing of the concrete, which in turn controls the cracking, which occurs in a large mass like this. And also the concrete has better durability, which is important in this marine environment.
Air-cooled blast furnace slag aggregates in concrete have been available for many years. The result is that more than 1 million cubic metres of slag aggregate concrete has been used over the past 30 years in the construction projects in Australia's steelworks, floors, walls and massive foundations, just to mention a few. One significant application was the use of blast furnace slag concrete aggregate for a 140-metre tall stack at the Coke Oven Battery.